All right, today we're going to work on lesson 713, Old Faithful's Next Eruption. So our objective for this lesson is to identify relationships between provided patterns. So in this case, it's going to be some in and out tables. We're going to graph ordered pairs for corresponding patterns. Our success criteria, we're going to accurately determine the relationships between provided patterns and graph the ordered pairs. Let's get started with the mental math here. We want to estimate our quotient. If you remember, the quotient is the answer to our division. So if we look here, I can see that this is pretty close, 18, and this is pretty close to either 3 or 4. Well, I can't do 18 divided by 4 in my head, or 18 divided by 3, but I could make this into 16, and I could make this into 4, and I know my quotient should be around 4. I could also say, well, 18 is pretty close to 20, and 3.5 is close to 4. I could divide that way, and I know my quotient should be somewhere around 4 or 5. That is helpful to estimate when you're dividing by decimal, so you can see where to place your decimal. We know it would be after the ones place. So let's look at this one here. So I have 659 and 7/10, and let's see, this is really close to 10, so I know I could do 10 there. And here I could just say 650 because it's pretty close. Or you could even say 660. Either one of those would work. And I know when I divide by 10, I just mark out my common zeros, and my answer should be around 65. Again, you could definitely do 660 divided by 10. And you use the same concept, mark off your common zeros, and you get 66. So I know that when I divide that out, I should be around 65 or 66. I know that my decimal should be after the tens place. Okay, our next one here, 314 and 5/10, and I have a half. So I don't want to really go up to 1. So here, it's pretty close to 300, and I like to work with zeros when I can. And so I know that half of 300 is 150. You could easily have just said 314 and split it in half, but I know my answer should be around 150. If I went up to 1, then it would be around 300, which would be way too high. All right, so now we're going to move on to the parts of our objective today with understanding some patterns and studying those, and then being able to graph some later. It says work with a partner to complete the tables shown below. Then talk about what you notice about 2 tables. So if you're home or watching this video, you probably don't have a partner to work with. So that's okay. Go ahead and pause the video, take a few moments, and try to see if you can figure out what to do with the rules. Okay, hopefully you've had took a few moments and tried to fill in the chart there. Hopefully you've noticed a couple things here. In this case, this in and out table has 2 rules. Typically we're working with 1. But here I see it says for the end, just add 1. So I'm going to add 1 each time. So I'm just counting by 1 as I go up. Here it says plus 2. So each time I'm adding 2. And again, a little bit different than in and out tables we've studied in the past. Over here, same thing. For the end, I'm just adding 1. And since they both have their own rule, you just take that rule and apply it straight down. So again, plus 2, so I'm going straight down. I have 104, 106, 108, 110. Now, hopefully you've noticed when I compare straight across, I see that the one here over here is 100 more each time, and I can check back 102. And I can even go down to 10, and if I look over here, it's 110, which is 100 more. So the right side table is the out is 100 more than the left out table. Now, what other formulas have we talked about this year? So think about, we talked about the formula for volume, so length times width times height. You could do base times height. We've talked about area, where you could do length times width. We've talked about perimeter somewhat, where you could add up all the sides, or you could do the length times 2 and the width times 2. So just think about it. Is there any other formulas or any other methods or algorithm formulas you could think of there? Now it says use the formulas displayed for class A and B to calculate the total costs for the trip if each class has 17 students for the trip. So let's go ahead and fill this in here again. So we know it's 2, 3, 4, 5. And over here I have 4, 6, 8, 10. So I'm only at 5, so I need to go up. But I notice a pattern here. Each time I'm taking the n basically and multiplying it by 2. So if I have 17 students, and I can multiply that by 2 because the n would be the students. So if I multiply that by 2, I end up with 34. Now if we use that same thought process over here, and we fill it in with this rule, and remember each time it was plus 2 and it's 100 more than what we had on the other chart. And if you remember, we noticed the pattern that it's the same as the out, but just 100 more. So if I have 17 students, and on the other side there, I would add 2, or make it 200, and I'd get 3,400, because it's 100 more on that side. So let's look at our answers. Oh, and I see where I made a mistake. So let's actually go back, and I realize what I did there. Okay. We actually want to think about it as 17 times 2 is 34 plus 100, right? We're adding 100 each time, not multiplying. That was my mistake. So hopefully you caught that before I did. So it would actually be 134, because what we're doing is we're taking the out from A here, and we're just adding 100 to the out for B. So go ahead and pause the video. I want you to see if you can figure out how many students would go on the trip if you had 25 students for A and then for B. And remember, the rule for A is multiply by students by 2. And for B, remember, you're multiplying by 2 and adding 100. So try 25 students and 83. So pause the video now and try those. Okay, hopefully you've had a chance to try those. So let's check for 25 students. Let's do a little calculation here. I know that 25 students and multiply by 2, I should get 50 students for that trip for A. And then for B, I'm doing the same thing, except for I'm adding 100 to my product. A little order of operations there, multiplication before addition. And I get 150 students. So let's check to see if we got that. Okay, so hopefully you figured that one out. And then next one, we would say 83 times 2, which should give you 166. And then you add 100 to that, and you get 266. So hopefully you can see the pattern that we are following there. Now, go ahead and turn in your math journal to page 272, please. So pause the video and go ahead and turn to 272. Okay, so now you should be on 272, and your page should look like mine. It says Old Faithful, one of 200 geysers found in Yellowstone National Park, is one of the nature's most impressive sights. Old Faithful is not the largest or tallest geyser in Yellowstone, but it is the most dependable. It erupts at predictable intervals, okay, so kind of at the same time, and we're going to look at a rule for that. If you time the length of one eruption, you can predict how long you would have to wait for the next eruption. The formula that describes Old Faithful's eruption pattern is, and you can see here, the wait time equals 10 times the length of the last eruption in minutes plus 30 minutes. So we will use that information, that formula, to help us. So let's look at our table here. So they have already told us the rule. We don't have to figure that part out, which is great. So we take the length of the previous eruption, and we multiply that by 10, and then add 30 minutes to that. So let's try a couple of these together here. So I would say 2 multiplied by 10 is 20, plus 30 more minutes would be 50. Use a different color here. Let's look at our next one here. I would say the length here. So the length multiplied by 10, which 3 times 10 is 30, plus 30 more minutes. So 30 plus 30 is 60. Now look down here at the very bottom. They tell us the opposite. So they tell us that we have 35 minutes. So thinking about that, I have to go backwards now. So I know I had 30, it says 35 minutes. I know that they added 30 minutes to it. So I have to do that and then divide. Instead of multiplying by 10, I'm going to divide by 10. So then I would say 10 divided by 5 is 2. Now, again, go back and look at that. So they gave me the wait time of 35 minutes. And so I have to do the opposite here. I know automatically when it's over here at 35 that they've added 30 minutes. So I subtracted 30 minutes from it. I was left with 5 minutes for the length of the eruption. And because it's the opposite of the end, I had to divide by 10. And we know 10 divided by 5 is 2. So I'm going to want you to pause the video and fill out the rest of this chart. When we come back, we'll look at it together. Also, you need to, over here, write your ordered pairs, and then we will work on graphing them. So pause the video now and complete that. All right, welcome back. Hopefully you've had a chance to look at that. So hopefully you were successful in doing that. We'll see now. So I know that I have the length again, and I multiply that number by 10. So 4 multiplied by 10 is 40, plus the extra 30 minutes, so I get 70 minutes. 5 times 10 is 50, plus 30 is 80. So maybe you're noticing a pattern here. And then 6 times 10 is 60, plus 30 is 90. And then you see a pattern that's going up by 10, but then they mix it up a little bit, put 2.5 in there. So let's look at when we got 2.5. So I'm going to say 2.5 multiplied by 10. And I can do that a couple different ways. Let's scroll down here and we can look at that. So 2.5 multiplied by 10 plus 30 is what we're working with here. So I'm going to make this an improper fraction. I think that'll be the easiest way for me. So I get 5 halves. I'm going to multiply that by 10 over 1. And I get 50 halves, or 50 divided by 2, which is 25. Take a minute, make sure that part makes sense here. So we just converted it to a mixed number. Mixed number to an improper fraction. I got 5 halves. I multiplied straight across. Got 50 halves, which is divided out as 25. Plus, I have to add in my 30 minutes, or 30 on there, as the formula dictates. And I get 55 minutes. And now we have to go and write our ordered pairs. So you can see they did the first one for you there as an example. Then the next one I would just say the x is 2, the y is 50. And then I would say 3, 60. Next one is 4, 70. 5, 80. 6, 90. Erase that mark there. And then we have 2.5, or I'm going to say 2.5, which is equivalent, and 55. And then 2 and 35. Now we want to go ahead and graph these ordered pairs so we can make a line graph. So let's do that now. So the very first one is 140. So I put my dot there, and I don't cross them out in case I need to go back and check, but I do like to put a check mark so I know that I've done it. And you just plot your points. And we go over 360 here, and 470, and just make sure they're lined up and you're graphing those accurately. 580, 690, so I go over to 6, I go up to 90, oh, I missed it there. So I go to 690 here, and again, just like I did, if you make a mistake, just go back, erase it, and fix it, and that's why we want to always use pencil and math anyhow. Now the next one's a little bit of a trickster. It says 2.5, so it's going to be halfway between 2 and 3, and it's going to go up to 55. So it's going to be halfway between 50 and 60. And our next one, 2, and then 35. So 35 is going to be halfway between 30 and 40. The great thing is they made the lines there for you so they can be seen. It seems like there's one thing not matching up. Okay, so we need to go back and look at this one here, because this is not going to be 2, because they should match up. So let's go back and look at our calculations for 35. So 35, I know I am going to subtract my 30, and I get 5, and then I have to say, I guess it would be 5 divided by 10, which is a half. So that could be where we made a mistake, but that doesn't. Yes, okay, so this would actually be a half, so I calculated wrong there, so that would actually be 1/2. So we'd want to change that to 1/2. Okay, so 1/2 from 35, there's where we made our mistake. Okay, and then you want to use a straight edge, and you want to make sure you connect your points. And remember, you would want to use arrows because on here, because it could definitely go past, we could measure it way past the length of eruption. 6 minutes could go even longer, possibly. So we would put our arrow there. Okay, now it says it will be 8:30 a.m. and Old Faithful has just finished a 4-minute eruption. About what time will the next eruption occur? Okay, so the last one to finish was at 4 minutes. So you see 4 minutes here. So then I want to go up to my graph, and I see 4 minutes, and then I look for my next point when it should erupt again. How long will I have to wait? So when will the next one occur? You can see it, you go over to 5, or sorry, the next eruption would occur about 70 minutes when you go across there. So about what time? About 70 minutes. So you can see at about 70 minutes, if you take your finger and just go all the way up until it intersects with that line and it interpolates, and you see that it is about 70 minutes you would have to wait. So then you're going to go through and explain your answer. Just explain how you use the graph, or you could even use the formula. So you can see over here they don't have force, but also if you look here at 4 minutes, it would be about 70 minutes. Oh, and actually, so let's look at this again. So I apologize here. That just tells you 4 minutes, but it's asking you, has just finished a 4-minute eruption, about what time will the next one occur? Okay, so what we need to actually look at is after 4 minutes, about how long until the next one. And you can see here the next one would be at about 80. So about 10 minutes you would have to wait because there's a gap of 10 minutes between the two. So 10 minutes later. All right, that is the end of the work in your math journal. If you would like to play this game at home, Decimal Domination, you can. I don't believe there's an online version of it, but you can also look it up on ConnectEd if you need to see that and you would like to play. So those things you need is number cards, 2 counters per player, 1 coin, and a calculator which is optional, and 2 players. So predicting decimal products, multiplying decimals to get the most out of points there. So I will put the directions right here. If you would like to pause the video and check that game out, you are more than welcome to do that. Otherwise, that is the end of our lesson.